Hi guys, I didn't get a chance to talk to you, so I thought I'd make a video on my thoughts. So my thinking is that the Sinha experiment doesn't actually measure the Sorkin parameter correctly. Let me explain why. So let me begin by writing down the Sorkin parameter. Okay, where PAB is the probability distribution when all three slits are open, which is equal to the sum of psi A, which is the wave function of a particle going through slit A, plus psi B plus psi C. PAB is the probability distribution when two slits are open, slit A and slit B are open. And PA is when slit A is open. So up to now, everything is perfect and theoretically correct. My problem is with the actual experiment. So let me write down the probability distribution of that is actually measured in the experiment like this. So PAB C superscript EXP is the probability distribution measured when three slits are open. And I'll write it like this, where N3 is some normalization factor. Similarly for two slits, and for one slit. So at the moment, I don't know what are the values of these normalization factors. They could be the same or could be different. And we'll talk about that because it's important. So now let me rewrite down the Sorkin parameter in terms of the actually measured probability distribution. Okay, so let me explain this, just to clarify. So PABC experiment EXP is the measured probability distribution for three slits, and similarly PAB EXP for two slits, and PA experiment for EXP for one slit. So if N3, N2, and N1 are the same, then the Sinha experiment is correct. But if they're not the same, then I don't believe they've actually measured the Sorkin parameter. So let's find out if N3, N2, and N1 are the same. Well, how do we do this? We know one thing. We know that the total intensity when three slits are open should be the same as when there's one slit open times 3. In other words, the probability distribution, the total intensity when there's three slits open should be the same as the total intensity of one slit times 3. So let me rewrite this like this. And therefore, N3 on N1 is equal to 3 PA dy over 3 PABC dy. And we know that this doesn't equal to 1. Therefore, N3 does not equal to N1. And so therefore, if Sinha were to correctly measure the Sorkin parameter, she needs to put in these normalization factors. And I mean, okay, I mean I think that's a proof that the Sinha experiment is not valid, I believe. But let me go on and make a few points. We know what these normalization constants are. For example, N3 is equal to 1 on PABC dy, which we can calculate similarly for N2 and N1. Okay, let me go back and also explain why, sorry, this should be, why this doesn't equal to 1. Okay, so, 3 PA dy is equal to 3 psi a squared dy. Okay, that's 1. 2 PAB c dy is equal to integral of psi a plus psi b plus psi c squared dy, which is equal to psi a squared plus psi b squared plus dy psi c squared dy plus the cross terms, psi a psi b dy plus all the other cross terms. So let me rewrite it like this. So these three things is equal to 3 psi a squared dy plus cross terms, psi a psi b dy, etc., plus all the cross terms. And when psi a and psi b are not orthogonal, these cross terms do not go to 0. Therefore, 2 doesn't equal to 1. Therefore, N3 on N1 doesn't equal to 1. Well, let's talk on Monday, but I thought I'd make this video for you to have a think about. Let me know your thoughts.